Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 7 of lesson number 9, Force and Laws of Motion. Now I hope you all might have revised with respect to the examples that we have discussed in the last class, and many of you might have even practiced it. Okay, now I want you to suggest one thing. Do one thing, that whatever example that we discussed in the last part, that is part 6 for the lesson Force and Laws of Motion, just alter the numbers, like take any numbers and try to calculate those. Okay, because you will be using the same formula, the same method. It's just that you will improve your calculation if you change the number and do the further calculation, as the calculation over here is also not shown. But if you do that way, that will help you a lot, so you can do that way as well. And I hope like every one of you have revised till the second law of motion. So like we have three different laws that Newton came up with, which we know it as like Newton's law of motion as well. So we are completed with two laws of motion, and we are left with the third law, which is like very small. But like there are many different examples and activities which are given based on that. And after discussing the third law of motion, we have one more topic on like on momentum itself, so we will be discussing on that as well. And like probably we need more two more parts, I guess, because there are many questions in the lesson. There are total like 18 questions that we will be discussing for this lesson, Force and Laws of Motion. So before I start with this part, I want each one of you to please revise each and everything, each and every note, like note that you have taken in your book, and then we'll proceed further. I hope every one of you have started revising. Or if you can come up with any doubt here, open to do that and ask. Okay, like you will get the reward from our end. So now I'm going to show you the slides one by one. You can even revise it from slide and just check if like something is missing from it or not, and even go through the pictures that they have shown. Okay. After discussing about like force in detail, like if you can check your notes, you might have written like the definitions for push, pull, and everything. Like there are many things that we have discussed so far, right? So we'll do that. We have even done that, so you can revise that as well. After this, we discussed on the effect of force, and we have like 4 to 5 points which have been given over here, and I want each one of you to please go through this slide as well, because this is the basic thing that you should be knowing, and like I know you know it, but please do revise this part as well. After this, we discussed on the two types of forces that we have. One is like balanced force, and the other one is unbalanced force, right? So I just want you all to please go through it as well. I hope every one of you are going through this slide. After this unbalanced force, if you remember, I told you in the last class that try to come up with different various examples with respect to like balanced and unbalanced forces. Like few of them have been given, but make sure like you even come up with your own examples. Like you observe everything around you and you come up with different examples for it. That will also help you a lot. Okay. So after this unbalanced force, we discussed on the first law of motion. So here we have like different examples about the like inclined plane, like many things have been given over here. So I just want each one of you to please go through it quickly. After this, we discussed about the inclinations over here and what problem like Galileo like exactly had. And after this slide, like on the next slide, we have about like Newton's part, what Newton did his research and what he came up with, right? Because on the basis of the studies that Newton did on Galileo's approach, like he came up with three different laws that we were discussing, right? But before that, I want you all to please go through this inclination parts. After this, we discussed about the Newton's, you can say, work and what exactly he came up with is known as Newton's law of motion. So here we have the first law of motion, which can be stated as like all object resist a change in their state of motion, right? And we also know this first law of motion as law of inertia, right? So you should be knowing it. You should not get confused with what is inertia and what do you mean by like law of motion, everything. Okay, so please go through it everyone quickly. After this, I hope you all are going through it, because after this, like, we have more explanation, a short explanation on it, and then we'll proceed further. After this, like, here we discussed on how the unbalanced and the balanced force, they can be illustrated, like, right? And we even discussed on the law of motion over here. So I just want each one of you to please go through it quickly. I hope everyone is going through this slide as well. After this, we discussed on this activity 9.1. So I just want each one of you to please go through this as well. After this, we even discussed on activity 9.2. So I just want each one of you to please go through it as well. After this, we discussed on this activity 9.3 as well. So I want each one of you to please go through this as well. After this, we even discussed on inertia and mass with respect to the seatbelt example. So I just want you all to please go through this as well. Then we started with the second law of motion. So I want each one of you to please go through it quickly. I hope everyone is going through the slide like this. Second law of motion is mostly been asked, so make sure you know it. Then here we have like about more about velocity and momentum which has been given. So I just want each one of you to please go through this slide as well. Then we discussed on like mathematical formulation of the second law of motion. So I want each one of you to please go through it as well. I hope you all are going through it. Now this slide is very important, so make sure you know it as well. I hope every one of you are going through it and you have understood like how exactly we came up with the formula for momentum and for calculating the force as well, right? So I just want you all to please go through this slide as well. Then we discussed like in detail about it. So I just want you all to please go through it. After this we discussed on the further part for it. So I just want you all to please go through it quickly. I hope every one of you are going through this slide. So sorry. Mm, so where were we? Yeah. So after this, like we had 5-6 examples that we discussed. So I just want you all to please go through it quickly. After this, we have 9.2 as well. So I just want each one of you to please go through it. I hope you all are going through the examples given. Then we had this example 9.4 as well. So I just want you all to please go through it as well. Then we had this example 9.5. So I hope you all are going through it as well. After this, now we have the third law to discuss. So, the third law is very easy, and mostly people also use it in, like, you can say, real life example as well. So, see, the first two laws of motion tell us how an applied force changes the motion, right? And they also provide us with a method of determining what force it is, right? So now we are going to study about the third law of motion, which states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. Now, one funniest example is like if you will slap one person, the other person is also going to exert another, like a slap on you, right? So whatever you're going to give, it is going to come back to you again. That is what third law of motion states. Like if one object is exerting a force on another object, the second object will instantaneously exert a force back on the first. So these two forces are always equal in magnitude but opposite in direction. What I said, the two forces are always equal in magnitude but opposite in direction. So the forces are going to act on different object and it's never going to be on the same object. Okay, so over here the difference is that the objects are going to change. The force is not going to act on the same object again. So when it comes to the game of football, sometimes, like while looking at the football and trying to kick it with a greater force, they collide with the player of the opposite team, right? This happens mostly in many of the cases. So both feel hurt because each applies a force to the other, right? Both the players are going to apply force. So in other words, there is a pair of force and not just one force. It's not only one force which is acting on that football. There are pairs of forces which are acting on it, right? So two opposing forces, they are also known as action and reaction forces. Like equal, whatever action like you will make, you're going to have equal and opposite reaction for that. Okay, so let us consider two spring balances connected together as shown in the figure 9.10. So can you see this two spring balances which have been kept? So action and reaction forces are going to be equal and opposite. You can come to know that from here. So the fixed end of balance B, now look at balance B, it has a fixed end, right? Through the free end of spring balance A, it is observed that both the spring balances show the same reading on their scale. If you see and like come up with it, you'll come to know that both the spring balances, they are going to show same reading on their scale. It means that the force exerted by the spring balance A on balance B is equal but opposite in direction to the force exerted by the balance B on balance A. What does it means? The force exerted by spring balance A on spring balance B is going to be equal but opposite in direction to the force exerted by the balance B on balance A. So any of these two forces can be called as action and the other one can be called as reaction. What can we call that as? Reaction. So this gives us an alternative statement of the third law of motion, that is, to every action there is an equal and opposite reaction. So this is what the third law of motion states again, that every action will have equal and opposite reaction, and we should always remember that the action and reaction always act on two different objects simultaneously. What do we need to remember? That action and reaction, they are going to act on two different objects simultaneously. Okay. Now I want you all to write all the important points about the third law of motion. I hope every one of you have started writing it. Here also we have some important points to discuss, so I just want each one of you to please go through it quickly. Sorry. I hope every one of you are taking note of it. Then we will discuss more, and I'll only discuss about the third law today. Now see, suppose you are standing at rest and intend to start walking on road. Okay, you're just standing now, but in few seconds, you're going to start walking on the road. So you must accelerate, and this requires a force in accordance with the second law of motion, right? If you have to move, if you have to accelerate, you need to apply force, right? And this we have already studied with respect to second law of motion. So which is this force? Is this the muscular effort, right? You have muscular force which is acting on your body, because of which you accelerate, right? So is it the muscular effort you exert on the road? Is it in the direction we intend to move? No, you push the road below backward, right? So over here, the road is going to exert an equal and opposite force on your feet so that you can move forward. So road and you are having an equal and opposite force acting, because of which we move forward. Okay, and it is important to note that even though the action and reaction forces are always equal in magnitude, forces may not produce acceleration of equal magnitude. The magnitude can keep on changing. Okay, so why is it so? Because force act differently on different object, right? Because the different objects can have different mass. So on the basis of that, forces are going to act differently on different object. So when a gun is fired, it exerts a forward force on the bullet, and the bullet there exerts an equal and opposite force on the gun. So because of this, there will be recoiling of the gun, as you can see in the picture that they have shown. And because the gun has much greater mass than the bullet, the acceleration of the gun will be less than the acceleration of the bullet. So over here, how can we imply the third law? We can say that the third law of motion can be illustrated when a sailor jumps out of a rowing boat. So over there, what are we doing? We are having equal, we are applying equal and opposite force over there, right? So as the sailor jumps forward, the force on the boat moves it backward. So like both the examples of the gun and the sailor are been given on the screen. So I just want each one of you to please go through this quickly. I hope you all are writing the points in your book. After this, in the next class, I'm going to start with this activity 9.4. Okay, so we'll discuss activity 9.4. Then we have to discuss on conservation of momentum. We will discuss on that as well, like different points under conservation of momentum. You already know what conservation, you already know what momentum is, right? So we'll study about conservation of momentum in detail. Then after that we'll discuss on like different activities and examples. So as you can see, we have this activity 9.5. We will be discussing on that. Then after this activity 9.5, we have like one more activity as 9.6. We will discuss that. Then we have example 9.6 again, which we will discuss on. Okay. After that we have 9.7 example as well. We will discuss that as well. Then 9.8. Okay. And then we have the summary discussion for the whole lesson, force and laws of motion. Okay, so we'll be doing that as well, and then we have 18 exercise questions to discuss. So I'm going to show you all the questions one by one, and I want each one of you to please go through it quickly. So these are the 18 questions that we will be discussing at the end of the lesson. Force and laws of motion. Now I want each one of you, like before you join with me in the next part, make sure you're revising each and everything. So we are still left with many activities and many examples altogether. Now I want each one of you to like revise it as I told, and I will be like continuing with the next rest of the part for the lesson in the next part. Thank you everyone.